Hello, we are Group 2032 and this is the Autonomous Firefighting Drone sponsored by Sikorsky Aircraft. Our group was tasked with customizing a commercially available unmanned aerial vehicle to demonstrate autonomous obstacle avoidance in flight while carrying a payload of water to be used in extinguishing a flame. Using a drone comes with many benefits. For example, since there is no pilot on board the aircraft, there will be no human life put at risk. It also allows the team on the ground to visualize a fire from an aerial perspective. The drone can also navigate through low visibility areas using an infrared camera and other onboard peripherals. Finally, the small size and light weight of the drone allows it to navigate through tight spaces much better than a normal helicopter. This is our final design for the drone. The body is a fully carbon fiber octocopter with a diameter of 1.2 meters and a fully loaded weight of about 8 kilograms. All 8 motors are Tarot 320 kilovolt motors equipped with 15-inch carbon fiber propellers that give us a total payload capacity of about 17.2 kilograms. Powering the drone and all of its peripherals is a 22.2 volt 6S LiPo battery mounted underneath the drone body. Controlling the drone is a Pixhawk 4 flight controller running ArduPilot firmware and communicating with the ground station using Mavlink serial protocol. The flight controller monitors all of the drone's attitudes and sends the required amount of current to each motor accordingly depending on desired movement. For global positioning, we are using a U-Blox Neo M8N GPS module that is connected to the flight controller and monitoring the drone's position at all times. It has an accuracy of about 2.5 meters, which is sufficient enough for our given mission. On top of the drone, we have an A2M8 360 LiDAR that we are using to detect obstacles around the drone and assist it in path planning on its way to the fire. The path planning algorithm we're going to be using for our mission is called Bendy Ruler. This algorithm monitors the proximity to objects in 8 equal sections around the drone, as can be seen in this diagram on the left. If an obstacle is detected within a 1 meter radius, the drone will slide alongside the object while also attempting to approach its final goal. This is demonstrated in this diagram on the right, with the blue triangle representing the drone and the green X representing the final goal. The algorithm is very simple, but is sufficient enough for our drone, which isn't expected to maneuver in very complex environments. On the back of the drone, we have a remote control receiver on the left used to manually override the autopilot in case something goes wrong throughout the mission. On the right, we have a telemetry radio used to relay information back to our ground station throughout the whole mission. Here we have our thermal camera, which is mounted onto a 2-axis gimbal that is pointed downward so that the camera has a clear view of the ground at all times. The gimbal is only made to hold GoPro cameras, so we 3D printed a box in the shape of a GoPro and attached the thermal camera onto it. The thermal camera runs a USB all the way to this black box, which houses a Raspberry Pi. The Raspberry Pi controls the drone throughout the mission by sending different commands and analyzing information from the onboard peripherals. It is wired to the flight controller, the thermal camera, and the water tank on the back. The entire mission script is coded in Python and uses the OpenCV library for video analysis and the DroneKit library for drone control. In total, the entire mission is about 200 lines of code. Once the drone detects a fire underneath it, it will align itself so that the water tank has a clear shot of the fire. The alignment process is done using a simple PID controller that controls the drone's X and Y axis velocities. This is a simple block diagram showing how the PID controller functions. Here's an example showing the drone aligning with a candle flame. This picture is before it has run the PID controller. After a few seconds, the drone has centered itself on the flame, which is shown in this picture here. Once the flame is aligned with the camera, the fire extinguisher will deploy. Due to the coronavirus pandemic, our group lost access to all the resources we were going to use to design this extinguisher, so we abandoned our original design and came up with this mechanism. The Raspberry Pi turns this servo motor, which opens up this tank and drops a water sprinkler. The water sprinkler has a lot of small holes in order to spread the water out onto a large area. After a few seconds of sprinkling the water, the drone receives a command to come back to its launch point, where it will land and the mission will end. This pretty much sums up our entire project. Thank you for watching.